In this video we are going to be creating a Bluetooth wireless car that can be controlled from our computer using Python. Let's first set up the Arduino, and then look at the parts needed. In order to use the Arduino with the HC05 wireless module, we will need to upload the PyFirmata sketch to it. First, plug your Arduino into your computer, open the Arduino IDE, select your board. Go to Examples, select Firmata and Standard Firmata, then search for firmata.begin and change the rate to 9600, as the HC05 Bluetooth module uses this baud rate as default. Then upload this sketch. You can now unplug your Arduino. Let's now take a look at the parts we will need for this project. We need 2 wheels that can connect to a TT gear motor, and 2 TT gear motors. TT gear motors are different from normal DC motors. They have a DC motor inside as well as a gearbox which translates the fast movement from the DC motor into a slower movement. A slower movement means the gear motor can handle higher torque. This allows the motor to move heavier loads than a standard DC motor would be able to. We then need a HC05 module which allows us to communicate with our car wirelessly over Bluetooth via our computer. We need an Arduino which will control when the wheels are powered and the direction they need to turn in. We need a DC motor driver which can be used to control our TT gear motors and handle more voltage than the standard 5 volts that the Arduino can handle. We need a caster wheel. I'm using a fixed caster wheel in this project as my third car wheel. It doesn't need to be able to turn, but you can also use a swivel caster wheel if you have one. We then need a 9-volt battery for our power supply, and a 9-volt battery snap connector. We need double-sided tape to stick our components down. 6 male-to-female jumper wires, 9 male-to-male jumper wires, 1 1000 ohm resistor, and 1 2000 ohm resistor. You will also need a breadboard, a screwdriver, and a pair of scissors. Cut a few pieces of double-sided tape and stick them to the bottom of your Arduino. We use a few pieces as a single piece of tape would be too thin to rise above the soldered parts of the board. Cut a few more pieces of double-sided tape and layer them on top of your DC motor driver. The make I'm using is the L298N, which will power and control 2 motors at a time. Finally, cut some more tape and stick it to the bottom of your 9-volt battery. We can now start sticking our components down to the breadboard. First place the battery, then the DC motor driver, then allow a gap and place the Arduino. Then place the HC05 Bluetooth module on the end column of the bottom portion of the breadboard. This will be the body of our RC car. Now let's attach 2 TT motors to the wheels of our car. These will be the back wheels. I have the connecting wires on the inside so that they don't catch against the wheel when it's powered. Add some double-sided tape to the top of the TT motor drivers and stick them to the bottom of the breadboard. For the front wheel, add some more double-sided tape and stick to the front of the breadboard. Now that our car layout is complete, we can start connecting all the parts together. First, connect the TT gear motors to the motor driver. On the motor driver there will be a set of 2 blue connection pins on either side of it. These are the out pins that will supply voltage to the motors. On the left set of out pins, connect the black negative wire to the first blue out pin by using a screwdriver and screwing it in place. Then connect the red positive wire to the second blue out pin in the set of 2. On the opposite side of the motor driver, where there are another 2 blue pin connectors, we need to connect our black pin to the first blue out pin, and the red wire to the second blue out pin. This will look like the wires are placed in opposite positions compared to the first set of connectors when viewing the motor driver face on. Let's now connect our HC05 Bluetooth module, which will enable us to connect wirelessly to our Arduino. First, add a 2000 ohm resistor between the ground bus of the breadboard and a few columns inwards. Leave 2 spaces before the end of the first section of the breadboard. Then connect a male-to-male jumper wire between the 2000 ohm resistor and the RX pin of the HC05 module, which is the second pin from the left. Then above the 2000 ohm resistor and above the male-to-male jumper wire, Add a 1000 ohm resistor which bridges the partition of the breadboard. Place the other end of the resistor a few columns away. Then connect another male-to-male jumper wire between the end of the 1000 ohm resistor and the TX pin of the Arduino, otherwise known as pin 1. This should make the connection between the RX pin of the HC05 and the TX of the Arduino. Now connect another male-to-male jumper wire between the RX pin of the Arduino, otherwise known as pin 0, to the TX pin of the HC05 module, which should be the third pin from the left. Then connect a male-to-male jumper wire between the ground of the HC05 module and the ground bus of the breadboard, and then connect another male-to-male jumper wire between the VCC of the HC05, which is the second pin from the right, to the positive bus of the breadboard. Then connect a male-to-male jumper wire between the 5 volts of the Arduino and the positive bus of the breadboard. Then connect the ground of the Arduino to the ground bus of the breadboard. Now, using another ground pin on your Arduino, connect a male-to-male jumper wire, then take the negative wire of your battery connector, which is the black wire. Both the black wire of the battery connector and the wire coming from the Arduino ground have to be connected to the ground of the motor driver. On the motor driver, this is the middle of the 3 blue screw connections. Make sure that both ground wires go into it, and use a screwdriver to screw them in place. For the positive wire of the battery connector, connect this to the left screw connector of the motor driver, which is where the power from the battery will go into. There should be a few male pins next to the 3 blue screw connections. There may be a few pin caps covering some of the pins. Take the caps off so that we can use all the available pins. You should see that the 6 pins are labeled. The first pin is called ENA, which the power to the left motor goes through. The second pin is input 1, and the third pin is input 2. Input 1 and 2 control the direction of the left motor, the fourth pin is input 3, the fifth is input 4, these control the direction of the right motor, and finally, pin 6 is the power to the right motor and is labeled as ENB, so you can think of the first 3 pins as controlling and powering the left side motor, and the last 3 pins as controlling and powering the right side motor. Let's now connect our Arduino to these pins. First, connect pin 3 on the Arduino to the 6th pin on the motor driver. This is the right motor ENB pin. Then connect pin 6 on the Arduino to the first pin on the motor driver. This is the left motor ENA pin. Now let's connect our direction control pins. Pin 2 on the Arduino goes to pin 3 on the motor driver, which is input 2 of the left motor. Pin 4 on the Arduino goes to pin 2 on the motor driver, which is input 1 on the left motor. That completes the controls for the left motor. Now let's do the right motor. Pin 5 on the Arduino goes to pin 4 on the motor driver, which is input 3 on the right motor. Pin 7 on the Arduino goes to pin 5 on the motor driver, which is input 4 on the right motor. This completes the wiring for both left and right motor controls. We now only have one more wire to connect to the motor driver. Connect a male jumper wire between the VIN pin of the Arduino, which is another power pin, and the 5-volt screw connection of the motor driver. This is the third blue screw connection in the set of 3. Our wiring is now complete. All we have to do now is clip on the battery connector. You should now see an LED on your motor driver light up, your Arduino flash as well as your HC05 Bluetooth module flash or blink slowly. It will blink slowly if you haven't paired it with your computer yet. I have a detailed video covering the Bluetooth module, but in short you will need to go to your computer. Go to the Windows search bar and type in Bluetooth, and then select the Bluetooth settings. Make sure that Bluetooth is turned on. If you don't have the Bluetooth option, then you may not have Bluetooth on your computer, in which case you can purchase a USB to Bluetooth adapter, like this one. It just plugs into your computer. Then the Bluetooth option will be made available. Once Bluetooth is turned on, select Add Bluetooth or other device. It will then scan for devices. Select HC05 from the results to connect to it. It may ask for a password. The default password will be either 1234 or 0000, then click Connect. This will pair the HC05 module to your computer. Check out my full Bluetooth connection tutorial for more detail. Now that we've connected to our HC05 module, we can start writing Python code to control our car. First, open up Python's idle and create a new file called Bluetooth car. Save the file, then import Arduino from the PyFormata library and the time library. We need to set up our board by referencing the COM port that our Bluetooth module is paired with. In my case it's COM5. We then need to define all our pins that connect to the motor driver. Pin 3 is digital pin 3 on the Arduino. It's a pulse width modulation pin. This is the pin that connects to the motor driver, which starts and stops the right-hand motor. Similarly, pin 6 does the same for the left motor on the motor driver. Pins 2, 4, 5, and 7 are digital output pins. Pins 2 and 4 control the direction of the left motor. Pins 5 and 7 control the direction of the right motor. Let's also create a speed variable and set it to 0.6. This will control the amount of power that is supplied to our motors, which affects their speed. It ranges from 0 to 1. If we provide too much power and our battery is low, then the motors can stall. If we provide too little power, then the motors won't turn at all. So you can play with this number to find the right balance for your battery and components. 0.6 works well for me. Now let's create a few functions to test that our car works correctly. Create a function called forward, and define the global variable speed. Then use the pin right method in pin 3 to pass it the value 0.6 from our speed control. Set pin 5 to 0 and pin 7 to 1. This is a forwards direction for the right wheel. Let's now do the same for the left wheel. Set pin 6 to our speed variable, and set pin 2 to 0 and 4 to 1. This will make the left wheel go forwards, so the function will make both wheels spin in the same forwards direction. Now create a new function called stop, which sets all the pins to 0, which will stop the wheels from turning. Now that we've got a forward and stop function, let's test them out. Call the forward function, then write a time.sleep statement for 1 second, then call the stop function. This will make our car wheels go forwards for 1 second before stopping. Run the code to test it out. All is working as intended. If your wheels aren't moving at this point, then there could be a few issues. Test that all the wires are connected properly. Check that the Bluetooth module is connected to your PC. Also have a play with the speed. Try setting it to a lower or higher value. If all is working, then we can continue to create more functions. First, comment out the forward, sleep, and stop statements. Let's create a new function called reverse. This is the same as the forward function, except the value for pin 2 is 1 and pin 4 is 0, which will make the left wheel turn in the opposite direction. And the value for pin 5 is 1 and 7 is 0, which makes the right wheel turn in the opposite direction as well, making the car go backwards. Let's also create a turn right function. Again, this is similar to the previous functions, except we want the left and right wheel to turn in opposite directions in order to make the car turn. So set pin 2 and 4 to 1 and 0, and then set pin 5 and 7 to 0 and 1. This will make the car turn right. Create another function for turn left, which just swaps round the values of pin 2 and 4, and pin 5 and 7. These are all the functions we should need to be able to control our car. Let's create a user interface to test that all our functions work, before assigning them to keys on our keyboard. Let's import a few more libraries. First import threading, then import Tkinter as TK, which will be the library we use for our user interface. Then from py-input.keyboard import key and listener. We will use this to track keyboard presses for when we assign our movement functions to keyboard keys. Now create a basic Tkinter window which has a black background, opens full screen, and has the title of HC05 connection. Then scroll down to the bottom of the script and write a window main loop to close out the Tkinter user interface. Next, let's create a button to call each one of the functions we have created, one for forwards, one for reverse, one for turn left, one for turn right, and finally one for the stop function. I've placed them all at around 300 pixels apart from each other on the x-axis. Each function should be a lambda function call. Now run the code and test the buttons out. It may be best to hold the car while testing just in case the stop button doesn't work and it drives itself into the distance. That seems to be working fine. Now we can assign each direction function to a button press on our keyboard. This will be more interactive than having to control the car with our mouse. Back in the script, create two variables called value and value2, then create a new function called onPress and pass the value of key to it. We need to assign a movement function based on if a key is pressed or released. I'm going to use the W, A, S, and D keys to map the functions, so let's run a check on if the key character W is pressed. If it is, set value to 1 and call the forwards function. This means if W is pressed, the car will move forward. If the key is not W and instead it's an A key, then we want to call the turn left function, else if the D key is pressed, call the turn right function, else if the S key is pressed, then we want to set value 2 to 1 and call the reverse function. If none of the W, A, S, or D keys are pressed, then we want to call the stop function so that the car stops whenever there isn't a key being pressed. As we've put all of the if statements inside a try statement, we want to write an except statement that handles any errors. If there is an error, we want the car to stop moving, so call the stop function. When a key is released, we want to stop the functions from running, reset the value variables, and call the stop function for every key. Let's write a few if statements to handle each key release like so. When W is released, set value to 0 and call the stop function. When S is released, set value 2 to 0 and call the stop function. For key A or key D being released, we want to check whether value is 1, as if it's 1 it means that the car is currently moving forwards. We don't want to stop the car moving if an A or D key is released while the W key is still pressed, so we can just call the forward function if that criteria applies. We also need to do the same for value 2 by checking if the car is currently reversing. If it is reversing and keys A or D are released, then we want to carry on reversing by calling the reverse function. If we're not going forwards or backwards when A or D are released, then we can stop the car moving. If none of the above if statements are true on release, then we can call another stop function, as well as handling any errors in an except statement with another stop function call. Now that we've worked out the onPress and release functions in which we pass through the value of key, we now need to actually call these functions whenever a key is pressed or released. To do this, we can create another function called getKeys and start a listener. Whenever a key is pressed, it calls the onPress function. Whenever a key is released, it calls the onRelease function. Finally, we need to start an instance of threading so that the getKeys function can run in parallel to the rest of our code. Set the threading target to getKeys and start thread 1. This is all the code we need. If we now run the script, place the car on the floor, and press the W, A, S, or D keys, we can see that our car moves and stops moving based on our key presses and releases. Hopefully this video has helped give you an understanding of how to control a Bluetooth car via Python. Thanks for watching.